Well, howdy, howdy, howdy. This is Mr. Dockin. You have entered Unit 4, the periodic table. Pick up your pencils, children, 'cause here we go. The first table was put together by a man named Dmitri Mendeleev. Now, this man did not know about all the elements, but he put together a table that arranged them according to something we like to call atomic mass. He did this back in 1872, so that was a long time ago when I was just a young whippersnapper. Woohoo! Now, a couple things you need to know about Mendeleev's table. He arranged it according to increasing atomic mass. The elements with similar properties were placed in the same vertical column. How fancy is that? And missing elements were yet to be discovered and were left blank on the table. You got it. He didn't know all the elements, but he was able to place them where they were supposed to be, even though he didn't know they existed. Man, slap my knee on that one. And then a young man named Henry Moseley said, "You know, Mr. Mendeleev, I don't think I believe you 100%. So I'm going to make a new table." And he was British, and he determined the atomic numbers of the elements. And you guessed it, he went ahead and put a table together that was arranged by atomic number. So if you look at my table up on the wall, Mr. Dawkins' there table, all the blue numbers are the atomic number. So that table you're looking at right there, well, that's Henry Moseley's table. How cool! His table is the one that is used today. You can find it on shower curtains, clothes, coffee mugs, you name it. We're going to talk a little bit about the organizational aspects of this periodic table. The first thing would be the periods, otherwise known as the horizontal rows of the periodic table. We have 7 of them, and in last unit, we learned a quantum number N, which was the energy level. And you knew that the energy levels could only go up to 7. Well, guess how many rows there are on the table? Yes, sirree, there are only 7. Another thing we're going to look at is something called periodic law. The periodic law is something that explains why there are so many patterns on the periodic table. When we arrange them according to the atomic number, what we see is a repetition of physical and chemical properties. Isn't that just something? The periodic table is organized so nice and neat. We just talked about the left and right stuff called the periods or the rows, but now I'd like to talk about the up and down stuff called the groups. The groups are the vertical columns of the elements on the periodic table. Groups are also known as families, and I'd like you to put a little puffy cloud around that. Whether you like it or not, young little gun, you behave a little bit like your family. And that's why we call these columns families, because if I take one column here, every single element in that family is going to behave a little bit like its brother or sister. True story. We have some other groupings that we won't talk about here. The representative elements. That's right, the representative elements. Group A elements are right here, and I am going to show you right there, and we got another one right over here. In the last unit, you learned that this was called the S block. That's right. And this one over here was called the P block. Well, these are kind of like the representative elements, except one thing. Those noble gases over there are pesky. They are special. They're like a rodent out in my fields that are destroying my crops. They don't like to be around anyone else. The representative elements are called the group A elements. So you'll notice on the periodic table, you'll see these little A's up top here. But you won't find them in the middle because those aren't group A. Couple of families in the representative elements would be the alkali metals. That is group 1A right here. Those are the alkali metals. Next group we're going to talk about is the alkaline earth metals, group 2A. right there. And you'll see that this is 1A and that is 2A. The next grouping would be the halogens. One more time, just in case you didn't hear it, that is the halogens. Group 7A. And the last major grouping of the representative elements would be the noble gases. 8A right there. But again, I like to put a little star next to these guys because they like to behave like nobody else. So they're kind of special. And it says group 0. I want you to change that and make sure you put in 8A. That would be the proper name there. One other thing I'd like you to point out would be that these guys do have names. This is the boron group. This is the carbon group. The nitrogen group. And I think you done dare guessed it, that is the oxygen group. We just call them by the name of the top element on that group. Group B elements is going to be what we're going to talk about next. Group B elements are the ones that are not the Group A elements. The transition elements is what they're known as, and I think you guys knew that already. The transition metals. Right down there in the middle of the periodic table. And then we have the inner transitions. This was the D block. The inner transitions are where the F block is right there. We call these the rare earth metals. Man, I'd like to get my hands on some of them rare earth metals. What you guys are going to do then there next is going to color in the periodic table after this video is finished. So don't do anything yet. Hold your horses there. I do want to talk about the colors, though. You are going to do the alkali metals in red, the alkali earth metals in yellow, the halogens are going to be green, the noble gases will be blue. But then there's some more. You're going to outline the representative elements in purple and the transition elements there in orange. And then you're going to put a legend right on the top. And that's going to tell me what the colors mean. I would also like to add the boron, carbon, nitrogen, and oxygen group. I'm going to let you guys pick any color or combination of colors that you want to. Get creative with it. Have some fun. We're going to classify some elements based on their properties. And I think you have covered this before, but these are the metals right here in blue. The metals are found on the left side of the periodic table. On the right side, we have the nonmetals. And right smack dab in the middle, we have the metalloids, or semi-metals. We can find these along the staircase, so I'd like you to pick up your pencils on that page, and I want you to draw the correct staircase here. It's going to go down and to the right, down and to the right, down and to the right. Couple of exceptions here. Aluminum does not behave like a metalloid. Are there any others that do not? I see another one right there. And one right there. That's right. Those are kind of the exceptions to the metalloids. Let's finish our notes today by talking about the properties of metals, nonmetals, and metalloids. Metals are malleable, which means they can be hammered and bent into sheets. Kind of like the way I made my barn with the tin. I had to bend the sheet of metal to get so that the rain wouldn't get in there and ruin my hay. Ductile means you can take that metal and draw it into a wire. Metals are always shiny and lustrous. They kind of look pretty sometimes. Good conductors of electricity and heat, and poor insulators of heat and electricity. Most of them are solids, except this pesky one right here. That's mercury, Hg. Nonmetals are brittle, but often form crystals. They are dull, which means they are not shiny. Think about that pencil lead right there. When it's scratched on your paper, it don't look too shiny. They are good insulators and poor or non-conductors of heat and electricity. We can have solids, liquids, and gases at room temperature. Now, the metalloids, they're special. They behave like metals and nonmetals. They have properties that are intermediate between metals and nonmetals. Fantastic. So next part of notes, we are finished today. You are going to take that worksheet that you picked up on the way in, and you are going to color in according to the color schemes that I gave you just a couple slides back. I want you to color in the metals, nonmetals, and metalloids with the colors of your choosing. So you've got a little bit of coloring to do. I left an example with the substitute teacher. You guys have some fun, and I will see you when I get back. Mr. Dockin out.